All right, thank you everybody. Sorry for the slow start. I have to say it's very exciting to be back in Korea again. I was here in October and lots of developers we spoke to were just waiting for a Chrome WebView. So I'm glad to be able to bring it to you and show you what this is all about. Okay, so what we have now is we have a new WebView in Android KitKat. Of course, this WebView is now built on Chrome or built on the Chromium code base. And so today I'm going to cover what the WebView is about, what it means to you as a developer, explain some of the debugging features that are in the WebView, and go through a few of the differences between the new WebView and the old WebView. So a very, very short kind of summary is all these points. What does it actually mean? What does it mean to you as a developer? Not that many people put their hands up about using the WebView here, so can I have a show of hands of people who know what the WebView is for? You don't know what the WebView is for? All right, if you're building an Android application, the WebView is a component that lets you use HTML, CSS, and JavaScript as part of your application. So the idea being that you can use web technology skills, but in an application that looks like a native Android application. And I'll slow down at that point. So what that means is if you want to do cross-device development, if you want to develop for other operating systems as well as Android, you can write your logic, if it's a game or something like that, in JavaScript, and then you pull the WebView in, and the WebView takes care of rendering to the screen. So the actual browser that ships in Android, the normal browser, uses the WebView internally. So Android prior to KitKat relied on the old WebView for displaying web content. So anytime you went to a web page, it was the WebView embedded in that application displaying on the screen. So what this means is that from KitKat forward, every single browser that uses the WebView uses the Chromium code base. And so what we currently have in KitKat is a snapshot of Chrome 30. Okay, so the WebView actually ships with Android for every release, and the current release is 30. So the features in Chromium version 30 are what you'll see reflected in the WebView. The difference between Chrome, the browser, and Chrome WebView is mainly in the graphics backend. It's all invisible to you as an application developer, but what has had to be done is chop out the back end of Chrome, the browser, throw it in the bin, replace it with a graphics stack that is compatible with the Android operating system. So Android developers here, who knows what Surface Flinger is? Anyone? One person? No people. Okay. Android graphics subsystem has a whole lot of things internally. There's Surface Flinger, there's a hardware accelerated layers, there's a whole view hierarchy. And so we've taken the Chrome code base, modified that back end of drawing to be compatible with the Android hierarchy. But as a web developer, you probably say, why does this even matter? Well, in the olden days, this is what we had in the WebView. So the original WebView from Android 4.3, 4.2 backwards all the way to 2.3 scored very badly on HTML5 features and testing. So it's got 284 out of 555, so not very good. In the last 2 to 3 years, there's been a huge acceleration in HTML5 technology in both APIs and features. And the result is that web developers who want to use these features in apps are asking for new functionality. So now with the KitKat WebView, we do a much more respectable 424. So what this means is that it's very easy to take logic that might be in a mobile website and translate it across into a native application that you can then publish on the Play Store and make money, which is always important. All right, so what are the new features? So here are some of the features that we actually have in the WebView that weren't there in the old days. So IndexedDB, that's a very important technology to store data on the device. Now, IndexedDB provides a really powerful database primitive. It runs asynchronously, so it's a non-blocking API. So, for example, if you build an HTML5 game, you may want to store lots of gaming levels in your application, so you can actually use IndexedDB as the storage mechanism for those games. WebSockets is a really good one. WebSockets allows a client application to talk directly to a server over a socket, very similar to a TCP socket in normal networking. So this means instead of having to do the poll response type of thing, you can actually push messages both directions from client to server and reverse. Very, very important technology. Request animation frame is a very, very new, well, newish technology. What request animation frame is it's a callback into JavaScript. And what happens there is that every time the browser, or in this case the web view, wants to redraw a frame, it calls back into request animation frame. Now the reason this is useful is for animations. So you can synchronize your animations on screen exactly to the refresh rate of the application. So you don't waste time. So in JavaScript, it's very common to animate by just setting a timer and redrawing every time the timer ticks. The problem with doing that is that you either draw too little or too much because you're not synchronized to the actual screen. So request animation frame does that, it synchronizes for you. Also there are SVG filters and effects. So with the new web view, we have a whole lot of different filters like sepia, convolution blurs, all sorts of different filters that you can then apply to any HTML content. And probably the single most important one in the Chrome WebView is the hardware acceleration. So the WebView itself is now hardware accelerated. The rendering in the view goes a lot faster than the old WebView. There are compatibility differences, which I'll talk about soon. But the most important thing is that Android is shifting to hardware acceleration for everything. So the default for all new applications is hardware accelerated on, and the WebView takes advantage of that. So if you turn hardware acceleration off, you'll have a very badly degraded performance. So there are a lot more features in HTML5, but probably the most important feature of all is the debugging features. Now, in the old days of the old WebView, it was very, very difficult to debug content. And the new Chromium WebView brings in the ability to use Chrome and all of Chrome's dev tools to debug. And so we see this little bit of code. That's all the code you need to add to your application to enable debugging. So I just want to do a quick demo of what this means. Okay, I have a phone here. So as you can see, I've got some applications running. So I've got this application here that I've built. Now this application is written using a web view. It's a little rolling ball game. You can see the little Chrome ball rolling around there. So if I go back to my browser, wherever it's gone, where's it gone? Right, so if I just open up a new tab, if I type in this address, Chrome:inspect, and plug my phone in via USB, what I find is that all of a sudden the browser has actually seen my phone that it's plugged into the laptop. So this is just simply a USB cable connected to my phone. To do this, we don't have to install any special software. There's no development kit or anything. It's a standard part of Chrome now. And if you see, I have this little inspect link. And that little rectangle there, the grey rectangle, is the web view running on my phone. So if I just click on inspect, it pulls up Chrome DevTools. So just a moment. So if I go out of projection mode and I try and find my little window here, you'll see that what we actually have is we have the Chrome DevTools actually showing me the content that's running in the view. So for example, if I mouse over things in the HTML here, you actually see that it's displaying what's actually on the phone. Right, so as I hover over, see the wall there that's gone blue at the top, that's actually a div in HTML markup. So all of these different walls in the game are actually divs. So you see, as we roll over them, we can actually see them. Now what's interesting about this particular example is that it's using some of the new HTML5 APIs. So it's using device orientation, And that means it's using the accelerometer. So if I grab my phone and I tip it, you see the ball starts rolling around. So that's actually using the accelerometer. But you'll notice that when I do that, down the bottom here, I'll just zoom in for that so you can actually see it a bit better. If you, oh, where's it gone? Oh, I fell into a hole, sorry. So my content's actually dynamically changed. I have to start the game again. Right. So if I go down to the bottom where the actual ball is, which is here, you'll see that as the ball is rolling around, you can see the DOM updating dynamically. So it's a full live view into the WebView content, which is really, really handy for debugging. So we can do anything. We can even edit this stuff. So if I wanted to, I can just come along here and change the colour if I wanted to. So we have black and grey. We could change this to red, say. And then all of a sudden, all of the balls, the holes that are in the game change to red. So you can do real-time live editing of your application if you're using the WebView. Now, what's really interesting about this is that the protocol between the phone and the browser is identical to desktop Chrome. What that means is that anything you can do on desktop Chrome tools, you can do with the WebView. So that includes analysing network traffic, looking at paint times, modifying the DOM on the fly, all these kinds of things. So it's a super powerful feature, and I know a lot of people have been asking for that. Right. Okay, let's just get rid of that one. Ooh. All right. Now, who here writes Android applications? Anybody? I do. No one else? You're just here to watch the show, is that right? All right, so what WebViews are about this new breed of application, like a hybrid application. So rather than building a mobile website, we're building a real Android application but using web technology inside. And that's why we call them hybrid. But one of the things that is really important I'd like to point out, if you decide to use the Chrome WebView in an application, what you should do is integrate with the native components as well. So before we heard all about the action bar and the navigation drawer and all of these components. We highly recommend you use those in your application. Now the reason to do that is that every time there is a new release of Android, they will automatically update. So your application won't go stale. So it keeps in synchronization with the platform. You should keep the WebView just for your custom content. So if you're doing a full page HTML5 game, sure, just use the WebView alone. But if you're doing something like a new social network called, Line App, instead of WhatsApp, Line App, and you want to basically sell that to Yahoo for $40 billion, what you should do is build all the framework and the menus and everything using native Android controls, and in the center where you have your content rectangle, use the Chrome WebView for that. So that's the way we like to go about using the WebView. So when you are actually building a hybrid application, times you need to talk to the native code, and the native code needs to talk to JavaScript and the WebView model. So we have a few methods of doing that. If you want to talk from the WebView out into the native code side, you can add a JavaScript interface. So there's actually a method that lets you put a new method definition in JavaScript, which calls out into Java and talks to native code. Similarly, if you want to run JavaScript from the native side into your WebView, you use evaluate JavaScript. So I'll just show you a couple of examples of that kind of code. So here's an example where we've added a new JavaScript interface. Can everybody read that okay at the back? No? Yes? This method. So this, add JavaScript interface. That basically takes two arguments. One is an object that defines the methods inside it, and the second is a string, which has been cut off on my slide, but it's the string which names the interface. So that's what you will see in the JavaScript side. So we have samples. If you want to actually go online. If you go to this particular repository, we have examples of code that you can just take and copy. So if you want to experiment with the Chrome WebView, just go to this GitHub repository, grab it, modify it. I encourage you to do that. That's what's so good about open source. Okay, so that lets you call from JavaScript back into native code. Now, there were a few people over here that used the old WebView. One thing we did find, like building the Chrome WebView was a very large engineering project. And one of the biggest problems that we had was the fact that HTML has changed in the time since the old WebView and now. And so there are a lot of behaviours in the old WebView that are undesirable and don't conform to current standards. So the WebView contains a compatibility mode. If you build your application with this manifest that says target SDK version 19 or higher, it will run in modern standards mode. If you build your application with SDK version 18 or lower, the WebView turns on a lot of behaviours that are meant to be more compatible with older applications, and this is purely for backwards compatibility. These two things that I've singled out, you should know are not supported in any mode currently on the WebView and probably never will be, so be aware. If you use narrow columns and single column for controlling the layout in your application, that's gone. What you can do now is use text auto sizing, which is a feature in the Chrome WebView, so there are workarounds to fix this. The other thing is the get default zoom and set default zoom doesn't do anything anymore, so they're just stubbed out. So if you're using those, don't use them. Okay, so let's move forward and we'll assume that you're using SDK 19 to compile your application. This is the behaviour you're going to see. You're going to see a user agent change, so the string that the server sees will be completely different, and it's different right here. Right there where it says Chrome 30.0.0.0, right? So now we actually have Chrome in the user agent string. So that means you can actually detect from server side or try to detect what kind of WebView is connecting to your server so you can send different content back. If you don't like the user agent string, you can actually change it. So if you want to get the user agent string, the default user agent, it will return this, and that's this method, get default user agent. If you would like to change it to emulate some different behaviour or to try and get different content back from the server, you can do it with the set user agent string method. Another change here is multi-threading and thread blocking. This is a hugely important one. Anybody that's currently using the WebView and wants to switch, you need to pay attention right now. Okay, the current version of the Chrome WebView has to run on the UI thread, right? So the old WebView, it was possible to run WebViews in background threads. Unfortunately, that's currently not supported. And what will happen is if you switch over to the new WebView and try to do that, your app will do very strange things and it'll be nearly impossible to debug. So you just cannot use it off the main UI thread. But if you really do want to run things from side threads, you can still execute into that WebView by using this method. There's the that little code that you run on UI thread. So if you have a bit of a closer look at that one, this will actually just let you run code in the WebView. So from a background thread, I can put the application logic in that method and it will send it over, take care of synchronization and do all the magic for you, and it will work. And so because of this and the new structure of the way WebView works on the UI thread, you have to take extra special care not to block the UI thread. So if you send off something in JavaScript and decide to sleep and wait, that's a very bad thing to do because your application will become unresponsive and Android will try and kill it. Now, if you want to actually run JavaScript off the main UI thread, rather than just trying to execute it, you can call evaluate JavaScript and that will run it asynchronously. So again, that won't block the main UI thread. So internally, the way the graphics work in the Chrome WebView, there's a compositing thread and there's the main UI thread. And so the compositing thread can be running in the background, doing animations while logic is happening on the UI thread. So the view itself is multi-threaded. Okay, another thing that's changed, most people probably don't need to worry about too much, but the way that URLs are handled has changed. When you're using custom URL schemes, you normally register a callback that gets triggered off every time it sees a custom URL to try and handle it. Now, the behaviour in the old WebView was very loose, so it kind of didn't work very well from a security point of view. So now what happens is that it's much stricter, which means that all of your URLs have to conform exactly to the RFC 3986, which specifies the syntax of a URL, and as long as you use that, you'll be able to use custom URLs. So here's an example of a URL handler. So this should override URL loading, that method there. That's called as a callback. So every time you click on a link or try and load a resource, this callback will be fired, and that gives you the opportunity to handle your custom URL scheme and what it is you're trying to achieve with it. There are changes in the viewport handling as well. A lot of people used to use this target density DPI, and that density DPI was something that would tell you what kind of screen you were on. This is completely deprecated because in the modern world, as we saw with the other presentations, we deal in like design pixels, not in actual device pixels. PX is not really used. So a CSS pixel corresponds to 1 or 2 or maybe 1.5 or 4 actual real pixels. So that's why the target density DPI is not there anymore. The viewport zooms in. This is a new behaviour. So if you said, my content is only 100 pixels by 200 pixels, the Chrome WebView will automatically scale it to fill the screen so that you don't have black borders around the edge or something. Now, multiple viewport tags are not supported. So people who are web developers use this meta viewport equals blah, 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 width is device width. There's a whole lot of tags to control how the viewport behaves, whether zooming works. In the old WebView, you could put 2 or 3 of these in with different values, and they would concatenate, put all the values together and use the union of them. In the new WebView, it's only the last one that is actually used, so be careful if you have existing content. And the default zoom, as I said before, is deprecated. So let's just see. Oh, styling, this is an important one too. So the way CSS works, there's a minor change in that shorthand CSS can override explicit CSS. So if you see this top example, we're setting the background size to contain, and then the background to a URL of an image with no repeat. Now that second line background is using CSS shorthand, which is a way to combine multiple things in one line. The problem is that overrides the initial setting of background size above it. So there's a very simple workaround, is to flip those 2 lines around. So these are only minor little tweaks, but you need to be aware of them. Now this is probably the biggest change, and I think this is just generally how Android and the world is going, that pixel densities on screens are increasing. So as designers, people want to actually design to a kind of physical look, not to shrink. If you have a super high res screen and then your tap targets are like impossible to touch. So window in the old view, window outer width and window outer height were actual device pixels. Now they're CSS pixels. And if you really want to know how many pixels per physical pixel, you can use window.device pixel ratio. If you don't want to do it from your actual HTML content, you can do it from JavaScript. Or you can do it from Java even. You can create something like this. You can create an interface that you register. If you registered this interface, then from JavaScript you could implement your own getScale method in native code that would then go off and probe the WebView object and return the scaling. Okay, so that's most of what I wanted to cover as far as how things are going with the WebView and how you need to use it. There's a lot of documentation online, but there are 3 key takeaways here. If you want to build a really great web-based hybrid application, number 1, always set your SDK version to 19. Right, I think that's become a general Android thing now. We're seeing rapid adoption of KitKat, and also one thing, I don't know if any of the sessions will be covering it here, but we spent a lot of time when we developed Android 4.4 to reduce the memory footprint. Now the reason we did that is so that it will run on phones with less memory. So we expect that over the longer term, Android 2.3 will just disappear because that category of phone with low memory is now capable of running KitKat. So moving forward, definitely use SDK 19. Turn on hardware acceleration. It's become crucial to a smooth user experience. So it applies for general Android applications as well, especially on the Chrome WebView. In fact, I think there's approximately a factor of 10 difference in render speed. If you turn off hardware acceleration on the Chrome WebView and you have graphics intensive stuff or Canvas or anything like that, you'll see about a factor of 10 times difference in performance. And of course, enable debugging. It's crucially important to make sure that you can actually debug the content that you have, because if you can't debug it, it's kind of a pain in the neck and you waste lots of time. So one of the best new features we have is this debugging. And if you want to, you can make that conditional, turn it off in your released application, or have it as a setting that you can change if someone wants to debug something out in the field, but highly encourage you to turn debugging on. And so, of course, since that's about it, we always have to talk about tomorrow. And what's tomorrow? I can confirm today that WebRTC is definitely coming to the next version of the Chrome WebView. So if you are building WebRTC-enabled applications, we see this as a real game changer. It's just democratizing communication. It's proper peer-to-peer video conferencing, data channels, everything. It's just been turned on for the current in-development WebView, and it will be coming very soon. So the next release of Android, you can expect to see WebRTC. I think last time we were here, and probably everybody I talked to about the WebView is, why no WebGL? Why no WebGL? I don't have a good answer. The simplest answer is simply a graphics architecture issue. So, as I said before, we pulled the whole graphics backend out of Chrome and replaced it with interface directly into the Android subsystem. So there are design and engineering challenges to actually make WebGL work with decent performance in the WebView, but we're certainly thinking about it quite a lot. And the other thing that we've been talking about doing, and we're still trying to work out how we could maybe do this, is the idea of making the WebView automatically update. So the current WebView, as I said, is Chrome 30 effectively. We would like to be able to update the WebView in synchronization with Chrome, so we have an automatic update mechanism, but there are a lot of engineering challenges to making that work successfully. So keep tuned and come to the next summit and we'll talk all about what comes out between now and then. So anyway, on that note, I've opened the floor to some questions. Here are some resources. So those two short links, there's documentation on the WebView on the left, on the new WebView, and a migration guide on the right, so if you're a current WebView user, open the one on the right. Those samples that are on GitHub is just a convenient short link to them if you want to get to them. In that case, thank you very much. Thanks for listening. Thanks for having me back in Seoul. It's great to be here, and I hope to talk to you during the day.